Hello everyone, my name is Ann Leslie Dean. I'm a software developer at FlightAware and I do web application development there. Today I'm going to be speaking about using Tcl with Apache Rivet with particular focus on interfacing it with JavaScript. Everything is the same. What do I mean by this? Well, my roots are in C and Fortran software development, and with an emphasis in geospatial data visualization, which is really just big words to say I like to make maps with computers. When you think about data visualization, you think about, ooh, pretty pictures, exciting, cool. But the reality of it as a software developer is you spend tons of time with the data. Either fixing your data so it doesn't break your software, or patching up your software to account for your glitchy data. So you spend lots of time just munging data back and forth. And so when I came to web application development, I have kind of the same mindset that a web application is just another data visualization. So you've got data, and you can put it on the screen so people can go, oh, beautiful, hopefully. Tcl and web application development. I really appreciate Carl's presentation previously. It really set the stage for why Tcl would be a good choice to use as a scripting language for web application development because of your ability to get up to speed fast. If you already have things in Tcl to access your data and retrieve it and prepare it, and you just want to make it appear on the web, it's nice if you don't have to reinvent ways to access your data. Which brings us to Rivet. Who, aside from FlightAware people, because at FlightAware we use Rivet, who has ever worked with Rivet before? So, 3 or 4 people? Okay. According to the Rivet website, Rivet is powerful, flexible, consistent, fast, and robust. It's essentially a server-side environment to generate HTML, CSS document using Tcl as a scripting language. It integrates with Apache Web Server. And if you want to find out more, you can go to their website. So there's a lot of layers of technology in web application development. It can be a lot to wade through, and it's kind of notoriously mind-numbing. For example, on the client side or the front-end environment, you have to contend with multiple browser environments, understanding web document markup in HTML and CSS. You need to know JavaScript, and then you have users that often want a user experience rivaling a native application. On the server side or the back-end environment, you can choose from different kinds of web servers, lots of different kinds of development tools, and many choices of server-side languages, but we're going to stick to Tcl for today. So, only a few outside of FlightAware here have heard of Rivet, but who's dabbled at least in doing a web page? Okay, so if you consider yourself more than a dabbler, raise your hand. Okay.
And if we've implemented a web server from first principles?
Keep your hand up.
No, you heard her. The whole time. All right, fine.
Okay, so all of us, or a good portion of us, have at least seen some HTML. This is a basic web document. It doesn't do anything fancy. It's just markup to output text in a web browser, and it says Hello, Houston. But if we add some JavaScript, bam, all of a sudden, it makes it interactive. You can click on it, the user gets to interact with the web page. And so that's why my talk is talking about JavaScript, because really any web page you deal with in modern web applications has JavaScript in it. If it doesn't, it probably doesn't do much. And we all want it to do something. So JavaScript is what transforms a web document into a web application. It enables the web application to respond to the user with customized UI interactions. And it enables the web application to programmatically update content. So what do I mean when I say programmatically update content? The normal pattern for a web document is to make a request to the server. The server packages up a bunch of content, sends it back to the browser, and the browser displays it. So that request and return is time consuming. And if I just want to change, say this were my web document, and I just want to change a couple of words in this, and I make a request to the web server, and I send back all the words again, that's more time consuming than if I could just say, give me the 2 new words that I want, and I'm just going to replace those 2 new words and not create a whole new document to do that. I just want to do a little bit of a change. So that's what I mean by making programmatic changes within the browser without making a complete new request to render the document. So that means it's not just a static document. Modern web applications are software. And so when you come to working with a web page, you need to think of it as software, not as a Word document that has some moving parts, but you should think of it as software. And you apply principles such as encapsulation, separation of concerns, abstraction. Essentially, you want to apply fundamental software design principles. Okay. Before I move on, anybody kind of going, you know, are the eyes starting to glaze over for anybody yet? Okay. It must be, because there's a lot of quiet. So, it's always best, in my opinion, when you come to some sort of software development program to have a focus. What are you trying to accomplish? And so you want to have a plan. Don't start without a plan. Whether it's quotable or not, you know, we'll see. So the plan for this case study then is to apply software design fundamentals. And since we're talking about a web application, we're going to talk about a couple of architectural distinctives for web applications. One is called presentation. Remember 1. 2 is content management. So what was 1?
Content management.
Yay. Okay. Presentation. For the purposes of this discussion, I'm just going to call that the code controlling the appearance and behavior of the web application. So that code essentially functions as a template for content. It contains HTML and CSS markup. It contains JavaScript code. Relies on Rivet directives. I know I'm starting to lose you right now. And it's dependent on abstract data model. So I'm just letting this flow over you. We'll come back to these as we go through the case study. Now, are you paying attention enough? 2 is content management. And again, for the purposes of this discussion, we'll call that the code which retrieves and prepares the data to be rendered into the web document. So there's some content. Again, this is kind of, you need context for this, but it uses Rivet directives to statically inject the data, aka content, into the HTML markup, which is your presentation. Uses Tcl to retrieve and organize the data into the abstract data model. So if you remember my statements about data visualization, you're spending a lot of time preparing data. That's what you're going to want to use Tcl for if you're using it for your web document rendering. And it uses JavaScript to dynamically alter content in the presentation. So we have 5 steps in my case study. Each one of these steps is you can consider it as increasing in complexity. However, it's increasing in complexity, but it doesn't necessarily mean if you're to do your own web page design that you would need to go up to the top level of complexity. Depending on your problem, you might find step 1 gives you everything you need, step 2, perfect. And another thing to think about as we go through this, sometimes we craft a web document or a web page from scratch, but often we don't. We work with someone else's code and we have to add to it or move around in it. And so you can also think of each of these steps as a possible point to move towards if you need to refactor a web document. So that's maybe sort of chaotic. You could think of, well, I can introduce a little order in this chaos if I move towards this step. Okay, the first one will be interesting to you if you've never used Rivet, or maybe not if you have no desire to ever use Rivet. So here's a bunch of code. And it basically puts on the screen a web page that has this text. It accepts an argument on the URL that if you pass the argument n equals 2, it displays example 2. So none of this is doing any kind of dynamic changing. It's just taking an argument on the server, rendering text in one or two alternatives. So in my Rivet script, again, I'm wanting to clearly distinguish content management from presentation, so I've chosen to put the Tcl, which prepares my data, at the top of my script, and put most of my HTML at the end of my script with only a little bit of Rivet to kind of glue the two together. And I like this because I'm very visual and I like to see my HTML as HTML and my Tcl as Tcl. So I don't have to mix and try to figure out what's going on there. If you've never used Rivet before, Rivet, it's kind of real similar to PHP. It allows you to basically do HTML templating. You can put Tcl between these two little indicators. Rivet commands they supply a library of Tcl commands that interface with Apache. as well as helper procs that boilerplate common web page tasks. This one here, load response, is a proc that takes the commands from the URL, puts them into an array called response. So now I can access them. It's down here, you'll see it in a minute. That's where the little N goes. Again, content management is about the data and preparing that. It's not about the layout or the appearance of the document. So content management on the left in Tcl, and we use the Tcl and put it into an abstract data model. My abstract data concept here is example. So there's examples put into content. We'll take a little tour of presentation, which is essentially HTML markup. We essentially are able to use almost pure HTML with little Rivet directives where we inject content from the data model. Okay, so in my opinion, when you're injecting content into the HTML template, Rivet directives are preferred. So you want to do this, not this. It is possible, since you can embed Tcl anywhere in a Rivet script, to do a puts and output HTML. Seems kind of ugly to me. However, limited embedding of Tcl into the HTML markup is sometimes expedient. So here's an example where I want to output an HTML table. Rows in the table are repetitive, and there's no for loops in HTML. So this is what my original web page looked like with just one example. I want to generate this one, so I put example 1 in row 1 of the table, example 2 in the second row. So I just embed a Tcl for loop around my row markup. So it's, it's not a hard and fast rule. It's just more rule of thumb to keep your Tcl out of your HTML. But rules are meant to be broken. Okay, so to recap, step 1. Again, remember our focusing rubric is to distinguish content management from presentation. General rule of thumb, Tcl for content management, HTML for presentation. Keep them largely separate and use Rivet as the interface between Tcl and Apache and Tcl and HTML. Point of this presentation, JavaScript. Again, bunch of code. This is what it looks like. We add JavaScript, so now I can click, toggles it back and forth. It's a lot more exciting than it was before. So JavaScript, whoops. JavaScript can be embedded in an HTML document by putting it between script tags. So that's what I've done here. I've used native JavaScript. What does that mean? That means this is the JavaScript that you have if you have a browser. You're not loading any extra third-party anything. And I've used CSS to configure the color. If you recall, the description was red and So it's all just, what you can do if you have a browser. Just, there it is again. So this was a pretty simple step to add JavaScript in. It's part of the presentation, so it made sense to contain it in the HTML markup, and CSS is also contained in the HTML portion of the document. So the next level is, so let's change the content dynamically. Remember, that's the example where you just want to change a couple of words. You don't want to re-render the whole document. Okay, first I'm going to load into my example a little bit of additional content. So this is back up in the Tcl portion. I'm setting content tip collapse and tip expand because I'm going to add a tooltip. So when you mouse over the description toggle, it tells you that you can do something. I'm also going to load a third-party JavaScript library, jQuery, into the HTML document. This is nice because it's going to give me a more attractively styled widget. And I'm using jQuery because there's a lot of literacy in jQuery out there. There are more popular and more modern JavaScript libraries that others might substitute in this capacity. So I use jQuery to attach a tooltip widget to my plus minus toggle. And then inside my on-click callback, I add the tooltip. I update the tooltip depending on whether it's toggle open or closed or collapsed. So again, we've added in dynamic change. So here's my tooltip. It says click to expand description. Now it says click to hide description. So that was a very simple example of using JavaScript to actually dynamically change the content of the document. Okay, so we added new abstract content. It initialized in the Tcl code section. And the JavaScript dynamically toggled the contents of the tooltip. But if you recall, this JavaScript is getting more and more complicated looking. And it's pretty typical and actually best practice as your JavaScript grows to not render it in the HTML document, but put it into a separate JavaScript file, which creates problems because then if I take this JavaScript that has these two little Rivet directives in it that are injecting my content in, how do I get my content from my Tcl code into my JavaScript code, which I just told you I'm getting ready to put in a separate JavaScript file that Tcl doesn't interface to. So this is going to be the after code. So we will explore. So when JavaScript runs in a browser, it interprets sequentially script tags. So this one is interpreted first, and then this one is interpreted. So what does this mean? Well, JavaScript has a wonderful global namespace. And so we can use the global namespace of JavaScript to save this tip content into the global namespace here, and then inside this script tag, and then inside this script tag, which now contains all of that, it can access content. So this works out really nicely. It's simplified my code and magically is pass content into the JavaScript. Now, if you haven't detected the cynicism in my voice, well, we'll move there next. So, but we've done some good software development things here. We've encapsulated the JavaScript and put it off in its own little tidy spot, and we've separated it from the part of, back up here. So we've encapsulated this here, and we've separated this little part into its own section, so it's no longer, quite so interleaved as it was before. Which brings us to step 5, which is, well, this global namespace business is really ugly. You should use modular JavaScript. Now, modular JavaScript is a pattern. You can Google it. There's nuanced variations of what I'm going to show you here, but it all kind of amounts to the same thing. So I didn't show you previously the contents of the JavaScript file because it was basically just a cut and paste of what you had seen in the document itself. Now we're looking here. What we're going to do is wrap all the JavaScript in a function. So now, when that JavaScript is interpreted, what will exist is a function called initialize application that takes an argument called tip content. Then in the parent document, I wrap it in what's called an anonymous function, which places all of the JavaScript that's going to execute in a contained namespace. It's no longer in the global namespace. But within Rivet, so before is above, and after tip content is set the same way, it's just now contained inside this anonymous function. I can call initialize application, passing tip content to it. It's very clear as a developer. I really enjoyed Andrea's habitable code comment. It's much more habitable. I can see what's happening. I can see where the data is coming from and going to. Okay, so tip content is the same. It's wrapped in an anonymous function. One thing we do have to do, application figure 5.js is loaded before the anonymous function because the function needs to exist before we call it, whereas in the previous before example, we just ran all that code after the tip content was defined. So we were able to eliminate the use of the JavaScript global namespace to share content with the JavaScript, but we're still able to share content from the Tcl environment into the JavaScript environment. And we use the JavaScript functions to encapsulate code. So we accomplished our goal of applying software design fundamentals. We accomplished our goal. We had a plan. We used presentation, distinguished from content management, and the end. Thank you very much. Any comments, questions?
It's been a lot of years since I looked at Rivet, but I see you're interpolating values into JavaScript strings. Does it provide any smart quoting and escaping to prevent that being a cross-site scripting attack?
We implement our own security measures of that, around that, yeah. So it's not a native thing to Rivet to take that into account.
So the visualizations you mentioned at the beginning, where do you generate those JPEG files, and is it on the server side? How do you bring the pictures inside?
So if you want to put a picture in a web page, for example, is that what the question you're asking?
Because you're analyzing data and making some things on the, let's say, map.
Right.
So where is this done? On the server?
So there's different ways. So you can put a picture in a web page, which is just a picture, like a PNG or a JPEG, as you said. And so there's, of course, we can draw a map on the server that is a PNG and just show it. And we do that in some cases. In other cases, we use JavaScript frameworks that accept data and render it into a map. There's several of them. Open Layers, Leaflet are very popular ones, but even like Google Map API can do similar kinds of things.
There's also a JavaScript plotting program.
Yes.
JPlot or jQuery plot or something.
Yeah. So yeah, there's lots of JavaScript frameworks to do things, everything from charting to map drawing to data tables and various things like that.
Are you using the canvas element at all?
Some of the frameworks that we use do use the canvas element, but we don't implement directly to it.
Just as a comment, in my dabbling for graphics or charts, I used actually scalable vector graphics in an image tag basically to generate something like a chart.
Hey, I know that we use handlebars or mustache for. Do you have to do anything special in order to get that to work for the HTML?
No, so Jonathan's bringing up handlebars, which is a templating package that you just need to, as long as you load the required JavaScript libraries, there's nothing special. Okay, thank you.
So with more discussion.